Hey all, Satish here. Today let's see how we can write the code for driving a LCD display. So we'll be writing the code to drive this display. This display is a 16x2 LCD display. Why 16x2? It has 16 characters in this way and 2 lines. That is why it's called a 16x2. And similarly, you also have a 20x2 also, 20x4, sorry. So that will have 20 characters this way and 4 lines. So the driver for both of them are the same. So let's so till now what we were doing was we wrote the code in PIC16 of 84. We selected this processor because this was the only processor which we were able to simulate in Proteus free version. But the issue with this is this only has 68 bytes of RAM and 1 kilobyte of program space. So with this space we cannot write much code. So basically we will not be able to write the display driver. So what we have to do is one, you have to figure out a way to get a Proteus full version. Then after that, only after that we will be able to proceed with this. So now for doing that we have to change the processor. So I will be changing to PIC16F877A. So that's a very commonly used processor. So and it's a pretty old processor also. Anyway, this driver, the drivers which I am going to be writing for this will be independent of the processor. So you can use it for any processor. So let's change the processor to PIC16 of 877A. So to change the processor, you have to come here, right click on this properties and change to PIC16 of 877A. The compiler is XE8. This is the compiler we are going to use. Let me apply. So before starting off, if you we have to set the configuration bits. So for that, I think it was in set configuration bits. So this has a different set of configuration bit. Oscillator we are going to use HS. HS is for a high speed oscillator, that is from, let's assume that we are going to use a 8 megahertz crystal on this. HS or XT also will work, I think, for 8 megahertz. Let's go with HS. We can go to the data sheet to find out what is the So here let's go to the oscillator section. It will be in special CPU features, configuration bit, frequency, HS, RC, XT and LP. So this HS, if you are using a 8 megahertz crystal, you have to go for HS. XT is for 4 megahertz, up to 4 megahertz. So will you go for HS? We are going to put a 8 megahertz oscillator. Then watchdog timer, enable on, power up timer. So let's enable this. I had explained about this in I think chapter 2. You can refer that. Brown note detect on, low voltage programmer on, code protection bit off, and let's keep this as it is. Generate output, and this we have to paste in our main. Again, refer the older chapter. This configuration for the older processor. We have to put this. Okay. So now you have set up the processor to start working. So now we should write the drivers for the header, the .h and .c files. So what I will do is I will give you in the description the .c and .h files where I have written the complete driver. Just include that. So this is the project directory. This is where we have our delay.c, delay.h, which we had written. So then let's new header file display.h. So here I have given you the driver, you can just copy paste from that, display.h. Or what you can do is you can include this files itself, copy it into that root folder and do this itself. Let me copy this for now. So I'll go through all of the code. Then we need a source file, display.c. This file, both of them I will give in the link in the description below. So we have to copy all of this. Paste this here. Okay, so before that, you see this display, these are the pins. So the ones which will be using ground VCC is for the displays to power up. This contrast, we have to put a pot and give the middle pin of the pot here and adjust the contrast. So more positive, either it will go to VCC or ground. I think it is towards the ground or towards the VCC. The contrast will become very bright. You can adjust with a pot. RS is reset and this is enable. RW is read or write. So we are not going to read from this, we are always going to write this. So we have to ground this pin. Then there is D0 to D8. So this display will work in two modes, means the data you can transfer either in 8-bit mode, means you have to use all the 8 bits. So this is a parallel display, you have to send the display data in parallel like 8 bits. Or there is another mode called as a 4-bit mode, means at that time you will only use D4 to D7. So instead of sending in 8-bit data at once, you have to split that into the upper nibble and lower nibble, the upper top 4 bits and bottom 4 bits, and send it in D4 to D7. So the driver which I have is for 4-bit mode. That is because or else if you go for an 8-bit mode, you have to use 8 microcontroller pins. So but the advantage within 8-bit mode, it will be faster. The data transfer to the display will be much faster. In 4-bit mode it will be slower because you have to split it up and send it as 2 packets. But anyway, this is not a fast display and the time is also very less. So just to save processor pins, we will go with a 4-bit mode, and this is the backlight. The backlight you have to give, again if you have seen the LED chapters, just go through the data sheets and put a resistor to limit the current. So basically we have to use 6 pins, that is data 7, 6, 5, 4, then RS and enable. So this is for the direction, the tris D is for the direction control. If you remember I think the second chapter in Microchip, we had gone through this tris bits. What tris is for direction control and port is for the data, high and low. So all these pins will be made as output and we will control the data through this. So in the display driver, what is useful is, first when you initialize the display, LCD initialize, you have to make all this, the RS, EN and all the 4 data pins as direction output. Then these are all the if you go through the data sheet of the display, you will figure out why I have used certain bits here, but you don't worry about it. So these are all internal things. What you have to write here is, one is LCD write character, means like for example you want to write a single character like A, you will use LCD write character. then write string. So let's assume that you want to write hi. There will be two characters. Either you have to write h, then write hi, I, or here you can write hi. Hi as a single string, and LCD go to is which position you have to go to. So what happens here is this is position 0x00, 01, 02, 03, 04, 05, 06, 07, 08, 09. It's not 10, it is in hex A, B, C, D, E, F. That is the address, and this line starts at 40, 0x40, 41, 40, 41, 42, 43, and then 4A till 4F. So when we write the code and when I simulate it, you will be able to understand that. First line starts with 0x00 in hex, and this is 0x40. Then I have certain other functions where you want to write a number, like for example you want to write a number called 22. So you can pass the number and number of digits. So in the number you have to pass 22 and write 2 digits. If you write 3 digits, what it will, this function will do 022. Write float means like 23.5. 23.5 if you want to write a floating number, right, pass the number of digits in the real part, that is 23. You can, if you write 2, it will write only 23. If you write 3, it will write 023, and in the fraction part 0.5, how many digits do you want? So these are the functions which we will mainly use, and these, for these two things to realize, I have written other functions here. You can just go through that functions or use the driver as it is. So in this display, either we will display a character, string, integer, or a floating. So these 4 functions you have to use, and go to which location you have to write it. Okay, that is the explanation of the driver. First you have to do LCD initialize. So that is the first thing you do. So now we have done this. Let's go to our main. So here I have to include display.h. Only then I can use those functions here. So as I told you, before you get in, you have to do in display.c LCD initialize is a function which you have to call. This will set up the LCD. So this will also make all the processor pins as output for these 6 pins. Then let's write a character. LCD go to is required for us. LCD go to main (0x00). Then we can write a character. LCD write character. So for character it is single quotes. Let's write exploring embedded, and for again it will auto increment. You don't have to write again. If it's a consecutive characters, you don't have to write again, write 0x01. If you write also, it's okay, but not required, because it will automatically increment to the next location. Then let's write string in main. So here let's write systems. So here it is expecting unsigned character. So you have to typecast this string into this one, else it will throw a warning. Let me build the code. Let me launch now the code has compiled. So let me launch Proteus. Start a new project. LCD. Now firmware finish. So I'll place my component from library. So you have to go through all my earlier chapters to figure out how to use Proteus if you don't know. So I had a playlist with all the basic where I explained all the basic electronic components, where I went through all the components like capacitor, resistors, inductors and all those things. And for the microcontroller, you can go through our PIC and Renesas chapter or playlist. So we'll select PIC 16 of 877A. Then let me take the display. Cross 2. Yeah, let's take this. Not this, this is a serial one. Yeah, we can use this. So if you see VSS, I'll connect it to, for this to work, place component or to terminal power. So for memory clear, so generally for memory clear we use an RC combination. So I'm just for the power up timer. So I'm now I'm directly connecting to the power line. I think the Proteus simulation does not need the oscillator. You can just select here and tell what frequency you are going to oscillate it at. So we are going to use at 8 megahertz. Then this place probe, not probe, it was terminal power. So then place terminal ground. This VSS 1 and 2 is for the internal working, and it's not shown here. If you go to the data sheet, this backlight, that is I think 15 and 16 is for the backlight. So in VEE is where you have to connect the pot. Proteus does not need that, I guess. So one to this, another terminal to this point, and read write I'll connect it to then RS. We have to go through our code. RS we had connected it to D0. D0, then D1 we have connected it to enable. Let's just check. Enable D1, D5, D2 was to A4, D2. So we are going to use it in 4-bit mode. D5 for data 7, D5 for data 7. Okay, we have this. Now we have to point it to the code, that is a file here. For that, let me build it. It's a very long path. Just copy it here. Production, and the hex file is here. Hex file. Okay, now let me start this. Yeah, E systems. So that is what we have done, and these two we had used for the old code where state machine code, the chapter before this we had used state machine, that is continuing to work. So this, I think Proteus doesn't mind whatever the voltage, it will show that contrast is not getting adjusted, but when you build the hardware, make sure that your contrast is correct, else it will not come or come fully dark. Okay, now this we have done character, string, and go to. Now let's do these numbers. For that, let me go to main. That will be very useful for you. For that, let me declare a couple of variables here. Int I number is equal to, let me start from 0, and float f number is equal to 0. So let me have a small delay here, millisecond, 500 millisecond. So if now I have to go to the second line, let me go to the second line, that is 40. Then display dot c, I'll take LCD long. The number is this. And number of digits you want. Let me have 4 digits. Means for 0 you will get 0 0 0 0 and 1 0 0 0 1. And also let me increment this after my use. Is equal to number plus, let me do 65. Okay, now after this we have float. So I will not write in 40, 41, 42, 43 is used up for this. Let me write in 47. The floating point number I will have number of real digit, let me have 3, let me have 2 in the after the decimal point, and I have to increment this also, that is f number is equal to f number plus, let me write 2.86. Let me stop this, build this. Then now if I run the Proteus will automatically load the code. So you can see that incrementing. So this is like 4 digits, that is what we did here, 4 digits, and here 3, 2, that is 3 for the before the decimal and 2 after the decimal. Let me put the LCD LED also here, so that that also keeps working. I can keep building on this project when as and when I go. I think it is called as animated LED. green, use blue. Let's use red. I think this Proteus does not need resistors. I think the animated LEDs. So practically you will have to use a resistor. I am just being lazy and not using a resistor. Okay, I have connected both of them to power. I have to place it to the terminal ground. So that continues to work at its own frequency, and this is also working. You have to always keep a time on the animation time. Sometimes if the CPU is loaded, this might not run real time. So it seems to be running at real time now. So that is how you use a LCD 16x2 or 20x4 with Renesas. So that is a driver. So in this driver what we have done is we have initialized, written characters, written a string, written a integer number, written a decimal number. So all that is there in the driver. I'll drop the link in the description below. You can download the driver directly for that. Okay, now let's drive the LCD from the Renesas controller. For the Renesas controller also I have, so this is where we had stopped last time. So please go to the previous chapters to see how this project has been set up and all these things have been set up. Okay, the drivers are here. I will leave the I'll give you a link in the description below. You can download it. So this is for the Renesas controller. Now I have to include it into the Renesas project. So for that the easiest way is file, add files. I have copied the files there. Let me just paste it here. So I have pasted .c and .h. You can see only .c because I have here it is only .c. If I do both files .c, .h, both have been included. I'll open it here. Okay, and the hardware. So we cannot simulate the Renesas controller, and we have not done it till now also in Proteus. In Proteus you cannot simulate Renesas. So we were using the inbuilt simulator to see the LED toggle, but now I have a hardware here. So this is the schematic of the hardware. Okay, this is where the LCD RS, E, D4, D5, D6, D7 have been connected. As I mentioned earlier, we are going to drive it in the 4-bit mode, and this was the 3 contrast adjustment. So I had asked you to use a pot, but since I know what is the values, will get the approximate contrast, I have put the resistors itself, saving cost. Okay, so now we have to map it. So in this driver I have already mapped it in display.h. I have mentioned what is what. Now all these pins we have to make it as output. In Microchip we did it in TRISC. Here there is a code generator. In Microchip also there is a code generator, but 877A does not have a code generator. So we wrote it manually. So here this supports code generator. So in future I will do classes with Microchip which have code generator. So if you come here, ports, so display, so the first port is port P0.1, 0.0, I have to make it output, port 0, both output. Then come to display.h, it is 3.1, port 3.1 as output, and then port 6.0 and 6.1 as output, port 6, both of these are output. Then next one is port 12.0, port 12.0 as output and generate code. So it will do all the configuration to configure that pin as output. And there is one more thing here. So even in microchip also, there's one thing which you have to remember is make sure that you have selected, for example, in here what happens is port 6, no, the output will not go high. It's like an open drain connection. Basically what it means is even if you go make that pin high, it will be float. It will not give you 3.3 or 5 volts which is required. Low will make it ground. So in that case, if you are using it to drive something as an output, you have to put a pull-up resistor. Or else what will happen is you might have in the code made it 1, but what will happen is it will not go 1 because it's an open drain connection. So pulling it up will make this pin go high. If you make 0, this point will be pulled low. So always make sure that you have selected the pins, and if you have any doubt, take individual pin, toggle it high and low, and using a multimeter check it out. Because I made this mistake a few times with few of the controllers where the output pin will not go high. Okay, now I have generated the code, everything has been done. So if I come here, it's reloading, I have to include my code. Include display.h. I'll just quickly go through the driver. So first thing what we'll do is the LCD initialize. LCD initialize, this will set up the LCD in 4-bit mode. Then LCD, which will be important for you is LCD write character to write a single character. LCD clear will clear the full display. LCD write character will write a single character. Write string will write a string itself. I'll show you what I mean by that. Then LCD go to. LCD go to is which location you have to go to in the LCD before writing. So I had explained this in the microchip one. Just go through that, the address. I'll just show you. So this is a display which we are planning to use. The first line starts as 0x00. Okay, the first line is 0x00, 01, 02 hex. It is addressed in hex, and after 9 it becomes 0A, 0D till 0F, and the second line is 0x40. Okay, that you have to remember. So in the microchip, let me just quickly open the microchip code. So this is what we had done. So this code will be compatible, as I told you, with any microcontroller. So let me just paste it here in our main. So what we are doing here is, before getting into the while one loop, I am LCD initializing. LCD go to 0x00, write character E, one more write character E. It will not write on the same character because once you do write character, it will auto increment the location to 01. Then once you write that, it will auto increment to 02, and here I am writing a full string. And I think in this controller it is not unsigned character, it is constant unsigned character. This is very specific to some display.c. It is constant unsigned character. Some IDs take it differently. So in this ID it is constant unsigned character. You are passing a pointer to the string. Then we had, I think, named a couple of variables, and the next thing that what we wanted to do is display numbers. So in the driver, what we had done, we had two functions. One was to display the let me put this at the beginning so that we don't forget it. In watchdog timer, I have explained it in the earlier chapter what it is. So I am going to location 0x40 and printing I number. So I number I have to do here. In Renesas, you have to do it here actually, where they have specified start user code for global variables. I think unsigned integer I number is equal to 0 and float f number is equal to 0. So these two, I number and f number. So right side I number comma 4 means 4 digits will be displayed. Even if you want to display 20, it will show 0020. If you write 5, 00020. And for float, the driver is in such a, you pass the float number, real part and the decimal part. For example, you have passed 1.1, here it will be 001.10. That is how it will be displayed. So you have to build this. Let's see if there is an error. There seems to be an LCD write character display.h is here. Let me have a look if I think okay, this W is small in this driver. In the driver it is small and write string is, so in both the the functions are named differently in both the drivers. Okay, now that error is gone. So now let me hook up the hardware and let me set up my phone so that you can see what is being displayed. Okay, now I have set up my phone to show the display. So before you initialize or something, whatever the previous value will be, that it will show there. So to run this, till now we were using the RL78 simulator to see the IO pin status. So now I am using a E2 Lite programmer. So let me connect to this. So this pin is used to connect to that. Okay, sometimes what happens is it might not load, it might give throw some warning. So that time what you have to do here is you have to go to E2 Lite debug tool, erase flash ROM, just do this, yes, then it will program. I have seen that sometimes it will not do this. So once you click on this code will be downloaded onto the thing, and let me run this. Okay, I think you were not able to see that. So it has come. Let me restart it once again here. So it will start from, once it initializes EES systems, that is EE systems, that is what we have written, and it is incrementing here 4. I number is equal to number plus 65, that is keeping on incrementing. Then our floating point number is incrementing. Hope you are able to follow that. Both the drivers for Renesas and Microchip I will drop in the link, plus both the codes also I will drop it in the link in the description below. Hope you are able to follow that.